This section finishes up our study on polynomial and rational functions, looking at inequalities. A polynomial inequality is an inequality just like we've been looking at in the past, where you've got a less than, greater than, less than or equal to, or a greater than or equal to. So to solve a polynomial inequality, first set it equal to 0, then you'll find intervals and decide where the intervals are satisfying the inequality. Just like when we were doing quadratic inequalities. So solve and graph the solution set. So this one is quadratic. The first thing we have to do is get everything on one side, so subtract 20 from both sides. I'm going to set it equal to 0 and solve for x. This one will factor. Factors to be x minus 5 times x plus 4. Set both of those equal to 0. And I'm going through this pretty quickly because you've done all that before, factoring and solving. Okay, and so we found that the solutions are at x equals 5 and x equals negative 4. So let's draw us a number line. And I'm going to put a dot. Well, not quite, but I'm going to mark on here negative 5 or negative 4 and 5 so far. Okay, so the next thing we need to do is talk about the intervals. So we need an interval from negative infinity to negative 4, somewhere less than negative 4, somewhere between negative 4 and 5, and somewhere greater than 5. So I just picked negative 5 for the first one, and we plug in to our original inequality, so negative 5 squared minus negative 5, and we want to see, is that greater than 20? So negative 5 squared, that's 25, minus negative 5, that's adding 5, so 30 is greater than 20, so yes, we work there, and then we move forward. The easiest one between negative 4 and 5 is 0. Is 0 greater than 20? No. And last, greater than 5, I just use 6. So that's 36 minus 6 is 30. And is 30 greater than 20? Yes. Okay? So we are less than negative 4 and greater than 5. And because we're not including, because we've got just a greater than, not a or equal to, then we either put a dot there, an open dot, or parentheses. And so to write your solution set, it'll be from negative infinity to negative 4, not including negative 4, and then picking up at 5, which is not included because it's not got the equal to under here, to infinity. Okay. Let's look at another example. Oh, here's a picture of it. So if we graph the line or the quadratic, I think I graphed here x squared minus x minus 20 is greater than or equal to 0, we can see that it is greater than 0 from here to here and from there to infinity that way. There was my number line. Okay, solve and graph the solution set here. So same type deal. We're going to set both of these equal to 0. It's already factored. We don't need to set x minus 2 equal to 0 twice. So we've got x equals 2 and x equals negative 3. We do need to take into account the fact that this has the x minus 2 has a multiplicity that is even. So at 2, the graph touches the x-axis, And since the multiplicity is odd at x plus 3, it crosses. So this touches will change things for us a little bit there. Okay, so we need to look at some intervals. Over here on the number line, we've got x equals 2 here, and x equals -3 there. And so for our intervals, we need less than -3. I'm just going to go ahead and draw this over here. So between -infinity and -3, then between -3 and 2, and 2 to infinity. Less than -3, we can put in -4, so we'll just say -4 minus 2 squared times -4 plus 3, and we're looking to see if that is less than or equal to 0. When you put that all in your calculator, you get -36, which is less than or equal to 0. Between -3 and 2, the easiest to put in would be 0. So 0 minus 2 squared times 0 plus 3, is that less than or equal to 4? So that'll give us 4 times 3, which is 12. And 12 is not less than or equal to 0. And last, greater than 2, let's use 3. And we get 6. 6 is not less than or equal to 0. So far, the only thing that works is less than 3. And we are including 3, so solid dot or bracket, whichever your homework asks for. And we don't have to mess with anything in this interval or this interval or deal with the touching. If we look at our graph, you can see here is, in fact, where we are less than or equal from -3 to infinity. So our solution is -infinity, including -3. So we put that in a bracket. A rational inequality is an inequality that deals with a rational function, so fraction. So solve and graph this one. Start by setting equal to 0, so we have to subtract 1. And then we're actually going to go back and get that 1 over so we can start solving for x. Multiply both sides by x plus 1. So we have 2x equals x plus 1. And then subtract x from both sides so that x equals 1. We also, with rationals, we also have to consider the domain. So not only set it equal to 0 in solving, but we have to consider the domain in our solution. The domain is affected by the bottom of the fraction. So we have to set x plus 1 equal to 0 and see that x cannot be equal to -1 on the bottom of our function. Right. Okay. So, when we draw our graph, we've got to take into account -1 and 1 both. For our intervals, let's look -infinity to 1, or excuse me, -1, from -1 to 1, and from 1 to infinity. So I'm just going to use -2, plug that in, and find out, is that greater than or equal to 1? -2 times 2 is -4, and -2 plus 1 is -1. -4 divided by -1 is 4. Is that greater than or equal to 1? Yes. For our second interval, let's use 0. Make it easy if we can. Is 0 greater than or equal to 1? No. And last, 1 to infinity, let's use 2. And we get 4/3, which 4/3 is 1 and 1/3, and that is greater than or equal to 1. So we're good less than -1, and we're good greater than 1. We found over here that we cannot be equal to -1. Even though we've got a greater than or equal to there, we cannot be equal to -1. So we have to put an open dot or a parenthesis there. But we can be equal to +1. So we'll use a closed dot or a bracket. Therefore, our solution will be -infinity to -1, not including, unioned with, including 1 to infinity. Let's look at one more example of a rational inequality. And here's a picture, by the way. We were looking at greater than or equal to 1, so you can see that there is an asymptote here at -1. And so that's why we would not include that. But all this is greater than 1, and then starting at, or greater than 0, and starting at 1 is greater than 0. And this is 2x over x plus 1 minus 1 that I've graphed there. Okay, so same deal again. Set it equal to 0. When we do, and we multiply by x minus 4, that gets rid of the x minus 4 altogether. So set both of those equal to 0. And then, of course, we have to take into account the domain again. So take the bottom and set it equal to 0. So we're also including a 4. So when we're looking at the number line, we're going to be considering -3, 1, and 4. So we need all those intervals there. From -infinity to -3, from -3 to 1, from 1 to 4, and from 4 to infinity. So I'm going to use -4 to begin with, and if we plug in -4 to our inequality, we get -0.625. Now, is that less than or equal to 0? Yes. Between negative 3 and 1, let's just use 0. You get 0.75. Is that less than or equal to 0? No. Between 1 and 4, I've used 2, and after plugging it in, you get negative 2.5. Is that less than or equal to 0? Yes. And for 4, I used 5. When you plug that in, you get 32, and that is not less than or equal to 0. So we know that less than 3 is good, and we know between 1 and 4 is good. We know that we cannot be equal to 4, so we have to have an open dot or parenthesis there. And then since we've got less than or equal to, then we are going to include the negative 3 and the 1. So we'll write negative infinity to negative 3, unioned with, we got to include the negative 3, unioned with, including 1 to 4, but not including 4. And the last example, it's going to apply a little bit here. And there's our picture. So you can see where it's less than or equal to 0 here. And here. And there's probably an asymptote there at 4. For the position function for a free-falling object is S of t is equal to negative 16t squared minus v naught t plus s naught. We've probably looked at this a little bit before, but v naught is the original velocity, this little sub-zero thing. We call it a naught for some reason. S naught is the original height, and t is in time. So example 3 says an object is propelled straight up from ground level with an initial velocity of 80 feet per second. Its height then at time t is modeled by S of t equals negative 16t squared plus 80t, where the height S of t is measured in feet and the time in seconds. In which time interval will the object be more than 64 feet above the ground? So, our function was S of t equals negative 16t squared plus 80t. And we want S of t to be greater than 64 feet. So we'll say negative 16t squared plus 80t has to be greater than 64. And then to solve from there, subtract 64 from both sides, set equal to 0. So negative 16t squared plus 80t minus 64 equals 0. It's helpful for this particular problem to factor out a negative 16. It will factor out nice and even. So if we factor out negative 16, you get t squared minus 5t plus 4. Now, if you get a problem like this and it won't factor easily, you can use the quadratic formula. Doesn't hurt to do that. Then we can divide both sides by negative 16, and we're just left with t squared minus 5t plus 4 equals 0. So that's nice and easy to work with. It will factor. negative 4 and negative 1. We'll multiply to give us positive 4 and add to give us negative 5. So set both of those equal to 0. And we get 1 and 4. So we go through the same process that we have been. I'm going to mark 1 and 4 on the graph. And then we look at our intervals. So from negative infinity to 1, between 1 and 4, and after 4. Negative infinity to 1, I'm just going to use 0. So we'll say negative 16 times 0 squared plus 80 times 0, and that needs to be greater than 64. We get 0 for all that, and that is not greater than 64. Between 1 and 4, I'm going to use 2. We get 96, that is greater than 64. And greater than 4, I'm going to use 5, so we plug in a 5. And we get 0, which is not greater than 64. So we know that we're good between 1 and 4. And this is just a greater than, not an equal to, so we have open dots or parentheses there. And so the solution would be between 1 and 4. And how we would write that is that the object is over 64 feet in the air, between 1 second and 4 seconds. And I think I've got a picture over here. Yep. So if we graph on here 64, y equals 64, something like that, then you can see between 1 and 4, the object is, in fact, above 64 feet. And that concludes the section on polynomial and rational inequalities and our sections on polynomials and rationals.